This is video 531, and the goal here is to talk about how to verify identities and evaluate expressions using the double angle formula. So we're focusing only on the double angle formulas, and those formulas are the ones you see on this slide here. The double angle formulas all take angles that are doubled and turns them into expressions where the angle is not doubled. So it relates an angle that's doubled with an angle that's not. Now let's take a look at how this will work with finding missing information. So it starts with looking at our information we have and drawing a picture. So we're going to draw a picture in quadrant 2 because that statement there, pi over 2 less than theta less than pi, means that theta is in between pi over 2 and pi, and that's quadrant 2. And then I add the sides of my triangle because sine is 3 over 5. Now I'm going to find that missing side x. Now the first thing I know about x is that it's negative because it's in quadrant 2. And then I'll use Pythagorean theorem. I'm not going to bore you with that here. You're going to get -4. So my next step is to find the exact value of sine of 2 theta using this picture. So my formula is, according to this double angle formulas, 2 sine of theta cosine theta. So notice I'm not finding the missing angle, I'm finding the sine of 2 theta. And I'm using this formula. So I know sine of theta, so I'm going to just plug in what I know. 2 sine of theta, and sine of theta is 3 over 5. And cosine of theta, according to my picture, is -4 over 5. I'm plugging in what I know from my picture. Now I just evaluate. Create 2 as a fraction, so I can multiply the fractions together, multiply across the top, and I get -24, and across the bottom, and I get 25. That is the solution to this problem. That is the sine of 2 theta. Let's take a look at another example. Now we have the tangent of theta is 1/2. Pi is less than theta is less than 3 pi over 2. And we're finding the exact value of cosine of 2 theta. So looking at the formulas, notice there are 3 formulas for cosine 2 theta. Any of these formulas will work. It doesn't matter which one. Sometimes you're going to pick one over the other because it'll be faster, but in this case it doesn't really matter. They're all related by Pythagorean identity. So sometimes when you're verifying identities, you might use double angle formula and you might use Pythagorean identity when you see things that are squared. So now we're finding the exact value. Doesn't matter which formula we use, but let's start with drawing our picture again. So we're drawing our picture in quadrant 3 because it's theta is sandwiched between pi and 3 pi over 2. Again, I draw the picture and I find the missing side using Pythagorean identity, but I don't want to forget that because I'm in quadrant 3, 1 and 2 are both negative. That's why it's important to draw the picture. Now let's take a look at our formulas and how we'll evaluate these expressions. So we're finding the exact value of cosine 2 theta, and let's just use that first formula. Cosine squared theta minus sine squared theta. So I'm going to plug in cosine squared, but first let's find it. It's -2 over square root of 5. Sine theta is -1 over square root of 5. I'm not making them proper yet because we're going to see where it takes us, because we're simply going to plug it into the formula. And let's see if it'll simplify and make itself proper. So we're going to square the first fraction. When we square fractions, we literally square the top and then we square the bottom because we're timesing the 2 fraction by itself. And so we'll end up timesing the top by the top and the bottom by the bottom. So square the top, square the bottom. Squaring the top, I get 4. Squaring the bottom, I get 5. Now, why do I get 5 in the bottom? Well, square root of 5 times square root of 5 will give you square root of 25, which is just 5. And I do the same thing with the right-hand fraction. I'm going to square -1 to get 1. I'm going to square square root of 5 to get 5, because that's taking care of this perfect square here. So the beauty is the fractions have the same denominator, so I'm simply going to write this fraction. Sorry, I'm messing my video up here. I'm simply going to subtract the numerators to get the final result of 3 over 5 because the denominators were both the same. And there's your solution to this particular problem. So those are 2 numeric examples. Let's take a look at an identity example for verifying an identity where we have a double angle. The double angle formula is important whenever you have an angle that is different than the others. In order to do this verification, we need to convert this inside angle to x. So we can't have 2x on the inside. The second thing you should realize is that we actually don't have a formula for cotangent of 2x. We only have formulas for cosine, sine, and tangent. So in order to do this, we're going to use tangent to help us. So let's start by turning everything over to tangents in this identity on the left. Okay, so I use the fact that tangent is equal to 1 over cotangent, or I should say vice versa. Cotangent is 1 over tangent, so I replaced everything with that reciprocal identity. Now I'm going to use the formula. The formula for tangent of 2x is 2 tangent of x over 1 minus tangent squared of x. But notice that my tangent of 2x is in the denominator. Well, a tangent of 2x in the denominator really can be rewritten as 2 times 1 over tangent of 2x. This 1 over tangent of 2x is really the reciprocal or flip of tangent of 2x. Isn't that what we did here? We took cotangent and flipped it and made it tangent. Well, to get this, I need to flip tangent. That's the reciprocal of tangent. So I need to take this value and flip it. And that's what I'll replace with in this second fraction. So here's me doing that now. 2 times the reciprocal of the tangent double angle formula. And the other one I'm just going to copy down. So notice what I did one more time. I took this and I flipped it and put it in here. Now let's take a look at where this takes us. First of all, the 2's will cancel. They're common factors on top and bottom. Probably a good idea would be to write in parentheses here so you can see that this is multiplying the whole thing by 2. And I see a 2 on top and a 2 on bottom and they cancel. Now notice that the denominators are identical. Thankfully, these fractions have common denominators. Since I'm headed towards an answer with a single tangent of x, I need to have this subtraction problem complete. So I'm going to create a common fraction with a common denominator. So I'm copying down what's in the numerator, 1 minus tangent squared of x, all over tangent of x, the common denominator. Now let's take a look at what this simplifies to. 1 minus parentheses 1 minus tangent squared of x will give me, well, 1 minus 1 is 0. That's going to go away. But I'm also going to do minus the tangent squared of x. Well, that's just going to be plus tangent squared of x because the minus make a plus. So I get tangent squared of x on top. Now let's take a look at why that is again in case you don't see it. I'm distributing that minus. Sorry, hold on. Let me go back here. Okay, I'm distributing this minus that occurred between this 1 and the 1 minus tangent squared of x. So this minus right here is being distributed and everything in the parentheses. So I copy the first one and I'm going to subtract the next one here, and then I'm going to subtract the negative tangent squared. So I end up getting positive tangent squared of x. So the numerator is essentially equal to that. Again, 1 minus 1 goes away, and I get just positive tangent squared of x. The next thing I'm going to do is simplify this fraction that I get, tangent squared of x over tangent of x. Well, there's a tangent on top and bottom that cancels. So I'm left with 1 tangent on top, which is exactly what I want, tangent of x. That was the result I was looking for. So those are the steps working out to getting the result and verifying this identity. So that's your verifying identity. Your checkpoints today are not verifying identities. I know that's hard to write in a Google Doc, a Google form online. So you're simply going to do, similar to the first 2 examples, try and evaluate those different expressions. So for the first one, you have theta lying in quadrant 2, and they give you tangent of theta. So draw a picture and use the formula and find the cosine of 2 theta. The free response question is if sine is negative 2 over 5, and you know the angle is between 3 pi over 2 and 2 pi, find the cosine of 2 theta. So good luck with that. Do your best to explain your work in the computer. Tell me what formula you used and how you evaluated that, and we will talk in class tomorrow. Thanks for watching.